We are going to be doing a detail from Detail Magazine, and the detail is going to be a two-part series. The first, in this video, we're going to do the 3D model of the detail, and the second part, we'll actually do the 2D detail line work to mimic this. It's from this project here, the Volkstheater in Munich, People's Theater in Munich, and we're going to be doing a detail of this facade here. It's a PTFE fiberglass mesh facade that's tensioned over a concrete-based structure with insulation and framing off of it. So it's going to kind of look like this at the end of the second video. And in this first video, we're going to do the 3D form that you see here. So without further ado, let's get going. We're going to be going through this script, which we should acknowledge is layers deep here, right? So we're running Revit. We're then running a Rhino.Inside plugin in Revit. We're then running Grasshopper inside Rhino.Inside inside Revit. And then within Grasshopper, we downloaded some plugins. So we have Kangaroo. So technically right now, this script is Kangaroo running inside Grasshopper, running inside Rhino.Inside, running inside Revit, just to make this. And admittedly, the facade is not the most beautiful facade, but technically it's so cool. So I really wanted to do this detail. I hope you enjoy it, and let's have a fun ride here. So what are the parameters in this script? Glad you asked. I can say, you know what, make this 9, make this 5, and it's going to go and create more resolution here. Bracket distance. So here I can go and change that, let's say to 2, and check that off. Now that's more about 2 feet out. So it's going to become much more drastic. And if I wanted to change that back down, I can just say 1. It'll be more subtle. Change the radius here to, let's say, 0.1, then the diameters on those brackets pushing and stretching out the fabric will become smaller. And if we go and let's say change that to 0.3, and they'll become more pronounced. And then over here, this is the grouping that then takes this geometry from Rhino that is being input into Rhino from Grasshopper, and Grasshopper, it's using Kangaroo, like I had said, to make the geometry. Anyways, this is all coming back into Revit. We're naming it fiberglass mesh facade. We're giving it a category of walls. So in that way, in Revit, we can filter and do graphic settings based on this category. So it updates with all the rest of the walls. Let's get into how to build it from the ground up. Take the detail from Detail Magazine and make the composition that is layering behind our bracketry and our stretched out fiberglass mesh. So what that ends up being, based on Detail Magazine's numbers in millimeters, the closest inch equivalent is 12 inches of structural concrete with then 6 inches of mineral wool above it. And that's fleece laminated mineral wool. So I have that as a membrane layer 0 inches thick. What you also see capping off the finished face exterior on this wall is another 0-inch membrane layer, which I'm describing as the fiberglass mesh. And in reality, that fiberglass mesh is being stretched out and away from the building. And here we actually see where that lands physically. Everything else that you see here, these brackets, that'll all be done in the second video in 2D. We need to make sure that we have the Rhino.Inside Revit plugin installed. Now, Rhino is a paid program, but it's relatively cheap. We're talking about hundreds of dollars versus thousands. And as of the time of this video, you get to keep the license. And you can even have the right to sell the license if it's not an educational one. So McNeil really is making a product that's affordable and pretty amazing. So thank you, McNeil, for doing that. Rhino.Inside is the plugin. So if you go to rhino3d.com/inside/Revit, and right now it's on version 1.0, I'm sure it's going to keep getting more and more amazing. But basically you just go and download that. And when you install it, it'll pop right into Revit as a tab. The other thing that you're going to need for Grasshopper then is the Kangaroo plugin. And in this case, in the time of this video, it's Kangaroo 2 that is out. And so I have the Kangaroo 2 download done and installed into Grasshopper. And that gives me a tab in Grasshopper to then run the physics-based engine that is Kangaroo. What's nice is Kangaroo is free, Grasshopper is free, comes with Rhino. Real quick, just for a moment, what is a PTFE fiberglass mesh facade? I wanted to just show a couple case studies based on its use, because the way I'm showing isn't its only use, right? We can use it as fin patterns. Here's a good example from Northwestern University. And these are some case studies that are on Flex Facade's website. So These photos are from Flex Facades by Structure Flex. This is not a paid promotion or anything like that. I just wanted to attribute for installing these. And this is a stretch panel example from Pleasanton, California. And here's one that is a parking garage done in Colorado that I believe Gensler designed. The artwork was commissioned. This is showing that you can imprint even artwork on flexible fiberglass mesh facades as well. So what is it? It's polytetrafluoroethylene, PTFE coated fiberglass ventilated fabric mesh. Provides an uncompromised and unequaled beauty, longevity, about 30 years. So that's pretty good. And functionality. It was developed in the 30s, actually, which is kind of interesting, and then started being used on buildings in the 70s, right? So I wonder what materiality exists today that is currently not being utilized. It makes you kind of think about that, because that went on for decades before it was architecturally used. The PTFE coating is very slick, so that's kind of nice. It's self-cleaning with rainwater, so that's a huge plus in my opinion. Let's make the Grasshopper script. So we have Rhino.Inside installed. Click on Start Rhino. Once that starts running, all these buttons will become available. Let's start with Grasshopper. So click on that. Grasshopper will open. You can just close out of the menu that pops up, and we can start building this script right on the canvas that opens up. I have bifocals installed and running right now. All that does is it gives you the name of the component that I used. So that way you can type it in yourself. If you double click on the canvas and let's say you start typing in face, you'll see that face component pop up. If you hold down Control and Alt and click on those components, it'll actually show you where those components came from in terms of the menu. So if you'd rather navigate the menus, you can do that. All right, so I'm going to click on that and delete it out. What we're going to do here is make this, but on this wall over here. I'm going to highlight this whole thing, Control C to copy, Control V to paste, and then I'm going to drag that down. The reason I have to do it this way is this face component, the way the script is run, can only be one face at a time, unfortunately, but that's just a matter of copying and pasting these down, and then you can just set your faces as you need. I'm going to right click and say set one face. I'm going to go and pick the face of this wall, and here you're going to see it's going to pick the whole wall, but let's say I don't want to do multiple walls at different heights or whatever. I want to do one wall. We can actually split the face of the wall in Revit and then rehost that here. So if I right click and just say clear values, then we can go into Revit here, click on the wall and use the split face command. Now the split face command, I then have to pick the wall again, the face that I want on that wall. So here I'm going to pick the outer face. And if I want to, I can do a pick lines command and use an offset. So here, let's say I want it to be maybe 10 feet down from the top edge, or I can go in and draw the face myself, right? As long as I'm drawing it from yellow line or orange line to orange line, or is that yellow? I can't really tell. And then you can check that off. This should be two different faces here. Let's see if that worked. So I'm going to go and say set one face. Yeah, there's the top face. So I'm going to click on that. That's how you really can have a lot of control in Revit on where this lands. We want to take that face and we want to offset it off of our host wall. So that's where the offset command comes in. S means the surface. So that's our base surface from the face. D means it's our distance away. And I wanted to do a addition of what we want the thickness of this material to be, because if this mesh is being hosted on the same face as this wall, what happens is Revit doesn't know which surface to show. They're competing against each other. They're coplanar. So we're going to automatically know that we need to offset that just a little bit. That way we're not colliding these surfaces together. Then the initial standoff distance, that's what I'm calling this. That is going to be 0.2. And these are just sliders that I made. So if you double click, you can type in like 0.01, enter, and that makes a slider from 0 to 1. And then you can also right click on those sliders and go to edit. And then you can go to the R rounding. And here you can have it rounded decimal places. You say okay on that. Now this slider has a ton of numbers involved in it, and that could be your input into the component. Then notice that this doesn't say slider here. On my script, I have it a little more descriptive. You can right click and type in your own custom. And then now it's this custom name. So it's a little more descriptive. Now, let me put this into a preview mode with Rhino so that way you can see what's happening here. Because what you're seeing in Revit is the end result. But I think to understand this Grasshopper script, you really want to see it every step of the way. Let's go to Rhino.Inside and we'll just do open viewport here. And here you can see that the face I have selected is here. The offset geometry then compared to the face is a little bit offset. Then from there, we are deconstructing that surface. That's what the deconstruct B rep component does. And we're flattening that geometry down into one list. We are then going to divide that into a subsurface of different frames. So that's what this is doing. And now that is then being, each of these surfaces are kind of being read on their own. And we're creating a cull pattern. And a cull pattern basically means that we're going to eliminate some of the surfaces. So here what we did is a cull pattern, bringing this subsurface geometry into one list. And in that list, we made a pattern. In that pattern, you can right click, set multiple booleans, true, false, and say commit changes, and it'll just go and repeat that pattern on a loop. And that then creates the pattern that we want. And then instead of doing like needing to type in false true, you can actually just right click here and say invert on here, and that inverts the pattern. So we have two opposite patterns now. Those two patterns I broke into a top side and a low side. These patterns then define which brackets are going to be where. The standoff bracket that's really close to the wall, and then the standoff bracket that's further from the wall. So then to know where the centers of those surfaces are, and this looks crazy right now, we have to then do an evaluate surface command and reparameterize the surface. Because right now, all of these surfaces have a relationship to each other. When we reparameterize that, well, they have a relationship to, like, let's say like the origin, and these are all kind of a certain distance away. When we reparameterize the surface, my understanding is we are now defining each one to have its own unique origin or its own unique value, whereas the parameters before 0.5 might have been some distance in space, and 1 isn't the ultimate value at the end. But now when we reparameterize a surface, 0, 0 on the surface would be like, let's say that bottom left corner of the surface, and 1, 1 would be the top right. So 0.5, 0.5 ends up being the middle. That allows us to extract out a frame from the surface. And that frame then is where we can say is going to be the base plane for our circle. And the UV on that frame is where the center point of our circle is going to be. So if I moved this down and around, I'm just going to go and drag that down. You're going to see all these circles shift based on the surface that they're associated with. Control Z to undo that. I renamed this circle component bracket circle A. And once again, you can right click, give it a custom name. But bifocals is telling you the true name there. Then we have a slider to then determine the bracket radius. So the same thing that's happening up here is happening down here to control both of those bracket circle diameters and their locations based on the cull pattern. And then we have the standoff bracket distance for that second circle. We can take the normal as well. That's the normal vector, the front face on that plane that was in the cull pattern. We can send the normal vector into the direction that we want to send our circle, and the amplitude, the force of that direction that we want to send our circle out from. We can use the move component, taking the geometry from the circles that came on the center of those surfaces, and we can move them out. We can see that now we've created these alternating patterns of circles. We have our mesh that is coming straight from deconstructed B rep, the initial surface, right? Offset out, deconstruct B rep, it's broken into a face, edges, and vertices. We're taking that face and we had subdivided it, and we're also taking that same face data and we're going to bring it in to make it a mesh. Now this mesh, we're going to take it and divide it much further, 80 and 80 in this case. So it has become a very, very extreme version of what we had over here, which was 9 and 5 pattern. This we wanted to know the center of our circles. But now over here, we want this mesh to be super, super high in resolution so it can form more like a fabric over those brackets. Then we're going to still take those circles that we had set. So here's the one set. Here's the other set. We still have that data coming from over here. So we have this high definition mesh. We're going to take all of the points that exist on the boundary as anchor points and inside that boundary of this mesh. And all those points then on the boundary are going to become anchor points in Kangaroo, meaning it's going to be fixed and they aren't going to move. The circle that we made, circle A, we're also going to take it and use its naked vertices to then make a ring of points around each circle that are going to become attachment anchor points that aren't going to move. It's going to force the mesh to stay on those points. We're also going to take the center of those arcs as just one additional control. So that way it's more of a flat face where the mesh is attached to those brackets. It just looks a little bit better so it doesn't like dimple in or protrude out. Those are going to be combined and brought in as anchor points as well. So we're going to merge those all together. So it's going to look something like this. And that's once again on every one of these circles. And same thing with the ones that are in more, same thing with the ones that are out more. Notice that this merge component is using the data from both circles, their perimeters, their naked vertices, as well as their center points. And that's going to be brought in as an anchor and reference to the closest point that is on the mesh. With that closest point, we are going to make the circles the target for where the closest points on the mesh relative to those circles needs to go. This is the part that confused me the most the first time I was making the script. So essentially, once again, we're taking that mesh, that main surface that we had from the very beginning, bringing it in as like one surface, making it very high in resolution. We are then going to take its boundary and say that's an anchor that is unforgiving, it's going to stay. All the points inside of it, we're saying give us the closest points and take the points that are basically from the brackets, points that are closest to those brackets, and move them to those bracket locations, to those anchor points. And so that's what that means between target and point. And the closest point, cloud points, that's the mesh. And we want to make those points that are actually the circles, the target for the cloud of points that's on the mesh. Hope I'm saying that clear. Then we also need to have for Kangaroo, in addition to these anchors, we need to have the mesh geometry. So we're taking the mesh that we made in that high resolution, we're bringing that in, and we're saying that that mesh then is going to have properties of elasticity based on length factor and strength. And those become like our stretchy components within that mesh. It allows that mesh to flex. Some of that mesh is already attached to the anchor points, so that's brought in here. And then we need to be able to show that mesh as geometry. So that same mesh component is split 3 different ways, right? Going in to create those points. It's going in to create this flexibility to it. And it's also going in to create what we want to see on the output of the solver, on the output of this solver. Then the solver needs to have the goal objects flattened down nicely into one list from our merge component. It needs a button to like reset the solver. So if I ever want to click it, you'll see that it's going to run the actual like physics-based engine based on the goal objects. And then we can also have a Boolean toggle to turn it on or off. So if I double click and it's off, then it's not going to run the solver again. It's going to like keep the data. It's going to like kind of dam it up so that way it doesn't keep flowing. If I go and run it true again and then do the button, it'll reset it and recalculate it. So if anything had updated, it'll show. It's going to output more than just the mesh geometry, most likely. So you can filter that with list items. If I hover on this, you see that there's actually 15,000 locally defined values that come out of this. A lot of them are null components, meaning like zeros. That's not an error, but the only thing we really need on that is the main mesh. And once again, you have to show that mesh into the merge, into the goal objects as show. And then that'll make sure that the mesh is part of the output. And we just want the first item on list item, which means that it's going to take, based on what it's saying here, is being output. Notice the first item here says mesh. That's the one we want. So under list item, the default here is just going to be 1, which technically is list item 0 because it starts at 0, then 1, 2, 3, 4. Anyways, essentially we're taking that first mesh item and getting that out. Then we can take that geometry here, one locally defined mesh. We can preview that here in Rhino as a custom material. Hold on. There we go. So this is our custom preview. So if you don't want to see like the translucent red preview that Rhino gives by default, and you want to see this as like a different material, that's what this grouping is. And that allows you to just show it differently in Rhino, but not in Revit. Here's geometry direct shape. So once again, Control Alt, if you click on it, you can see it's in the Revit tab under the direct shape tools under add geometry direct shape. To be able to get these little yellow text boxes on these panels, basically all you have to do is double click, type in // and then hit enter. And there you have a panel. This is just a text panel that then can be used to import data into different components. And so in this example, we're using this panel just to have text importing into the component, which will then feed into Revit. Type that, connect that into N for name. C is category. And so if you go and do category direct shape categories, once again, Revit, under direct shape categories, that gets you a nice kind of searchable list of categories that currently exist in Revit in your project. I'm giving this walls as the category. That way graphically I can control what's being shown in Revit through view filters or through graphic settings that I might override in Revit. So if I want all my walls, let's say to be like a halftone gray in Revit, this will now fall into that wall category. So when I do that in Revit, it will be included with all the other walls. Then I have a relay on here in between the geometry. So if you double click on one of these lines, it makes a relay. And on that relay, if you select it, right click, you can enable or disable the relay, which is kind of cool. And that allows you to stop data from flowing through. So if you're experimenting with different parameters and different values in Grasshopper, you can stop it from previewing in Revit, which will help maybe your computer move a little bit faster until you're ready. There's a material tool, and there's a bunch of different ones, but basically if you click on material, and this one you can see is from Revit Elements material. So parameters, Revit Elements, there's material. You right click on that, you can pick and search for any material that's currently in your Revit project, and you can feed that into this component as well. So that way, graphically, it's being shown as the material that you intend through Revit. And with that, it should turn black when it's all good. Otherwise, it might turn a different color like orange or whatever if it's not receiving everything it thought it would need. Red means it's not going to work. Orange means it didn't get exactly what it was expecting, or there might be something that's not being shown, some kind of null value or whatever. But in black, it means that everything ran exactly as it was thinking. At least that's my understanding of it. And so we should be able to then see that update then in Revit. And at that point in time, you probably don't even need the Rhino previewer. And here you see that we used Rhino.Inside really just to run Grasshopper and Kangaroo. And we didn't really need anything further in Rhino in this case. However, you could be drawing items and curvature in Rhino. If you need to reference that in your Grasshopper script, you're welcome to include more geometry in Rhino and ultimately send that back into Revit, even though it never initially existed in Revit. So that is the script in a nutshell. To dive into Kangaroo just a tiny bit further, here you see in the Kangaroo tab, there's so many different tools, and I would recommend looking at some further tutorials if you want to dive deeper in it. The solver, the anchor points, the edge lengths, like this, and this all came from Kangaroo. So here's the main solver, anchor point, edge length, mesh edge length, and show. So hopefully that helps you build it. Once again, if you don't want to build it or go through all that, you're welcome to download it from my website, studiohero.co. Thanks for watching. Don't forget to save and subscribe, and I'll see you in the next video as I make a construction detail of this wall.